Vineyard, and I just recently graduated from Bard High School. I am an incoming freshman for college, and the project that I've been working on is the obstacle avoidance robot. And so, as you heard from Jesse, I had 3 weeks ago I got ACL surgery, so I tried my best. I tried my best to get this done. So like you said, I didn't get any modifications, but let's get straight to the point. All right, so just an explanation for this base project. I'm sure you've heard from Antonio and Ayush. They also have this kind of similar robots, but it's basically a robot car that can ride around the house, outside, anywhere of your choosing, avoid obstacles. As it gets closer to an object, it uses its sensor. It will back away, turn in a different direction, never hitting a single object. I found this project to be more intriguing, and not only that, it's a robot that can run around my house without having the trouble of hitting anything. And in my case, I try my best. It both hits and avoids things almost half the time, depending on how well you code it. I've never done anything like this or had anything like this, so this will be my first, and that's why I chose this project. I will be video sharing with a video of my second milestone. Hopefully you guys can see this. So yeah, I'll play this video and I'll explain what I've accomplished. So for modifications, like Jesse said, I didn't have any time because of the surgery to get any of my desired mods done. But what I will say is that one mod that didn't count as a standard procedure that I installed recently was the moving ultrasonic sensor. Since most obstacle avoiding robots, they just mount the sensor in a stationary position, I had mounted it on a micro servo, right? And which is a servo motor that can, rotate in 180 degrees, 90 in both directions. And so I put my sensor on top of it and had the sensor look left and right. Once the sensor detects a very close object, the robot comes to a stop, and my sensor will look left and right and scan the distances. It will scan them and measure these distances in terms of which is further, right? By doing that, it both emits and receives ultrasonic waves. And if the distance to the left is further than the distance to the right, then the robot will turn left, and vice versa. As you can see, it's bumped into like, 1,000 of the over 1,000 times. Mainly because it can't, detect anything within its view. So you can see the ultrasonic sensor is always facing forward. It really can't detect anything at an angle. So it'll just hit it without any detection. So that's the problem. That's one mod that I had time for, but the desired mods that I had come up with at the beginning of the program, I couldn't do. I did plan to do them in the future. Some of those mods that I come up with was a built-in camera that I can access when I'm like not home or something. Also during the night when I'm in bed, and I can access the camera. But when it's nighttime, the robot, automatically turns on night vision, and maybe I just want to see something at the night. I have a cat, and maybe it'll pick up my cat in night vision. Another one would be manual speed alteration. A button where you can just increase or decrease the speed of the robot using my phone. That would have been cool. Another mod could be lights, some in the front, some in the rear, like regular cars these days, obviously. Or lights in between the car where it could just emit wherever. And another I thought of was sound. It could give off sound. If the battery's too low, it's about to run or up, or it has reached an area where it can't get out, I can stop sharing. It'll just emit a sound saying that, oh, hey, I'm stuck. I can't go anywhere. Put me somewhere else. So those are the mods that I thought of, that I thought of doing, but I couldn't do it. Some challenges regarding the project. I'd say I've had many. I'd say that during these 3 weeks of the working on the robot, the hardest component to work with was the motor driver. Given that I had 4 motors to plug into the motor driver, the problem was that the wires wouldn't stay put into the motor driver. This was both a mental and physical struggle for me, because the motor driver had screws so that when you plug in the wires, you can screw them down and they would stay put. But for the first 2 weeks, I had to deal with them constantly popping out because the screws wouldn't budge. They wouldn't budge, or no matter how strong or tight I would try to unscrew, they wouldn't budge. Just imagine wanting to test out if the motor will work, and to do that, you need to plug in the wires, and they just keep coming out. It was a pain, a major pain. But I renewed the motor driver, so I had to put screws. That was the hardest component to work, in my opinion. Everything else was genuinely easy. to me, since putting stuff together and coding was something I had experience with, and so I only had, one real challenge. And for the lessons learned, one thing I learned at this program was to be able to solve my own problems. Even if you have no clue how to do it, use everything at your disposal to try and figure it out yourself. You'd always want to try and learn things for yourself. Otherwise, you won't be pulling anything from the program. Your learning experience will basically be for naught. And I've learned that throughout the whole 3 weeks here. And in essence, try your best to figure out the answer to your problems without seeking out too much help. Nothing wrong with asking questions though, but you know what I'm trying to get at. My favorite aspect was witnessing my creation work. When I would see the robot stop and turn, I felt at ease. There may be some problems with the sensor and reliability, but I saw that every move it made was a step closer to finalization. Other than that, I really enjoyed my journey with the Blue STEM engineering program and helping me build this obstacle avoidance robot. This definitely helped boost my confidence in which career choice and majors, that I would like to pursue in college. Given my current condition, due to recent injury, obviously, no, this program helped me keep my mind on the right path and has solidified my choice to be a computer engineer. And other than that, I'm very grateful for this opportunity and experience. Thank you for your time. Any questions?
I just want to compliment you on your video. You did exactly the right kind of test to show what your robot had to cope with.
Thank you.
Yeah, I had
Yeah.
Oh, sorry. Keep
Go
going,
ahead.
Brendon. My bad.
Yeah. I mean, the only thing that's bothering me was the fact that it bumped into so many boxes. And, I don't know. It's just bugging me so much right now. But yeah, you can go ahead.
Yeah. So I just wanted to ask you about, kind of what it was like to kind of figure out, because you didn't have access to your computer for the first bit. So like, how it was to come up with all these unique solutions to be able to assemble the thing, and you found like an app to upload code from your app instead of the standard Arduino IDE. So like, what did it like kind of take to come up with these, continuously come up with like these unique solutions to the problems you were facing?
That's literally like the end of what I said, the lesson learned, try to figure out everything yourself instead of asking. I was in bed for like the first week and a half, so I didn't have any access. So I used my phone. I found an app that literally worked perfectly so I can run my code. I went on Google, many YouTube sites. The internet is available to literally everything. So I use that to my advantage. And for like I said, some of the code, since this is my first time building a robot, I had to use some code online, but obviously I'm gonna, go and do some edits and revisions because I want to learn. You need to learn something. I've had the help with my instructor, Jesse. Other than that, I'm gonna be honest, it was a struggle for the first week and a half. But I mean, I got it done. I got the robot done, and that's everything.